The Global Mitigation Potential Atlas, GMPA, helps you visualize decarbonization opportunities through collaboration. Let's dive in. With the completion of Phase 2, GMPA now includes countries across 6 continents. To see more details, select a country by clicking it on the map or searching for it. You can see how much emissions you can reduce in each country at different additional average abatement cost points. We can also see additional average abatement costs to reach net zero. Also, the trade-off between costs and emissions to build an energy system to meet all demands in the Pareto abatement cost curve, the PAC curve. On the y-axis, you have costs, and on the x-axis, you have emissions. To dig deeper, you can view the dynamic version of the PAC curve, the DPAC curve. With the dynamic PAC curve, visibility is unlocked, allowing clarity in planning. The DPAC curve gives clarity for target setting, as it lets users explore the trade-offs between costs and emissions. Perhaps a country has set overly conservative targets. The DPAC curve shows that we can be more ambitious and reduce a lot more emissions with very little additional cost. Perhaps a country has set overly ambitious targets. The DPAC shows plans that are still ambitious but more realistic, a target that is overall more achievable and agreeable. After setting targets, users can also see the portfolio of technologies and actions to invest in to reach the target at the least cost. We can then hover or click the individual technologies to see associated policies for that technology or country. This allows us to dynamically decide ambitious yet achievable targets and mitigation plans. Let's see how international collaboration can increase efficiency to reduce even more costs and emissions. We can add up to 3 other countries into a collaboration to see the biggest benefits. Collaboration increases the number of emissions that can be reduced at different additional average abatement cost points. We can also see this in the PAC curves that shift down and to the left when we go from autarky, no collaboration, to collaboration. Shifting down means demand can be met with lower costs. Shifting to the left means demand can be met with lower emissions. Let's see the status quo first. Diving into the details, in autarky, without collaboration, we can reach net zero with an additional $35 billion per year. But with collaboration, the additional cost to get to net zero is down to 22 billion US dollars, which is 37% lower. Once again, as we explore different emissions targets, we can see the breakdowns of the actions and technologies that need to be invested in. These actions can be taken in each country or between countries. Let's see another case. In certain countries' cases, net zero is not possible using just domestic action. As an example, Singapore is alternative energy disadvantaged. Even if we cover the whole country with solar panels, we can only meet 5 to 10% of Singapore's electricity demands. Thus, there is a mitigation gap in the PAC curves. This is where we need collaborations. Now we see how partnership produce meaningful potential at different cost levels. If we look at the new PAC curve, we see that with collaboration, we can get to net zero. What a stark difference! Let's dive further. In autarky, the cost is broken down into segments by the DPAC curve. Seems like net zero is ultimately not possible. Click on Full Collaboration. With collaboration, we can see that the mitigation gap is covered and we can reach net zero. Not only that, we can see that with collaboration, we can reach net zero at 9% lower costs than business as usual. And of course, Action Segments Visualization is updated automatically based on the plan that you choose. GMPA ultimately enables efficient and informed decision-making.